Saxon Advanced Mathematics. This is the homework problem for you, Vivian, that you requested. It's 2119, and I want to copy it down the way it's shown in the book. Well, first of all, I want to do this. John shows it in this presentation, and I'm not going to take the time to write it all down, but he has a big long thing here plus a big long thing here. It's got multiple bases and it's got some exponents. And then he's got another big thing here and then a minus sign. And when I noticed this pattern of two parentheses being multiplied, each one with a plus and the other one with a plus or a minus in the middle, I realized that what we're doing here is we're multiplying binomials. All of those crazy looking exponents, which I'm going to write down in a minute, complicate it and make it look like, oh my gosh, is it something else? But all we're doing here is just multiplying binomials, which we know how to do. I call it the dance, right? I stack the two binomials and then I multiply up and over. She sits down, then I go to the other one and she goes up and over. So we're going to do that in just a minute, but we're also going to refresh, before we dive into this, our rules for exponents, particularly the product rule. Remember that if we're multiplying matching bases, we can go ahead and just add the exponents, right? That's a rule. I've been beating it into my students for years, ever since Algebra 1. I started on this. So hopefully your mother beat it into your heads too. But one thing that's super important to remember in this problem is that those bases have to match. If they're different bases, you can't add the exponents, okay? It's only when they match. So that's an important distinction for this problem. Now that this is, again, let me write this down. This is the product rule, okay? So I looked at the basic shape of the problem to tell me what my basic strategy was. I remembered a key piece of information that I would need to know in order to do this successfully. Now I'm ready to write down the two binomials. John presented them in this format. I'm going to stack them. I'm going to write the first one on top, which I'll do it down here. 5x to the a minus b plus y to the b minus a. Look at how complicated those exponents are. But that's okay. We're going to use our product rule and we're going to be okay. So that's the first binomial. And then the second binomial I will write underneath. It's x to the b minus a minus y to the a minus b. No wonder you were confused. My gosh, what a mess, right? So let's multiply this. Again, it's the dance. We go here first and we multiply up. Okay, we multiply the 5s first. 5, and there's no other number, so it's 5 times 1. Now, we've got matching bases here and we're multiplying them. So that means we add the exponents. So I'm going to start with the top. It's, oh, I need the x. I need the base, don't I? And those match, so we're good. So it's going to be a minus b plus b minus a. Make sense? I'm adding these two together according to the product rule. Whew, that was a doozy. Okay, now we're going to go over here. It's positive. Now, this time, the exponents, or the bases rather, excuse me, the bases do not match, so we cannot combine the exponents. We just have to leave it as it is, right? So it's x to the b minus a times y to the b minus a. Okay. That's done. Now we're over here. And we're going to multiply this one times this one. This is a base of a y. This is a base of an x. So again, we can't add the exponents. They're going to have to just stay the way they are. And I quickly glanced to see, okay, is it going to turn out to be like this? And I see, no, it's not, because this is y to the a minus b. This was y to the b minus a. This is x to the a minus b. This is x to the b minus a. I was hoping these would match so that I could add these two, but it's not going to be like that. So, sad story. So when I multiply this times this, I get minus, and I'm going to put it over here because it's starting a new column, minus 5x to the a minus b y to the a minus b. All right, there's the minus sign. This is exactly the same, and then I'm just multiplying it by this. There's that minus sign, okay? These are complicated. Hang on. All right, last step is going to be to combine these two. Now they're matching bases, so I'm going to be able to use my product rule. This is on y's. This one is on x's, so they're not going to match. But since I've run out of space, I'm just going to write it back over on this side. I'll probably go down a little just so I have a little more room. It doesn't necessarily match up because it's a different base, but that's the best I can do. So this will be, it's this times this, minus y to the b minus a plus a minus b. Okay, so I added these two together. All right, let's see what we can simplify and do with all of this. Let's start here. Now what we can do is see if we can combine this. Look, it's a minus b. These two cancel, and these two cancel. So then this ends up being 5 times x to the 0. Weird, right? This stays the same. That doesn't simplify at all. B minus a, that's an x. Those stay the same. This, there's nothing that simplifies there, so I'm going to write minus 5x to the a minus b, y to the a minus b. Okay, that's a little squishy, but these are the exponents on those bases. And then here's my fourth term, which I now have room for over here. It's going to be minus y, and let's compare these. Oh, look, minus a and plus a, positive b and minus b. So this is going to go to 0 also. Okay, we're going to go through it one more time, and this time we're going to recall, and I'll put it here. Any base raised to the 0 power equals 1. So that means this x to the 0 goes to 1, and this just becomes 5. That means this y to the 0 goes to 1, and that just becomes minus 1. So I can combine the 5 and the minus 1 and get 4. Does that make sense? Both of those bases went to the 0 power, so I can completely eliminate them and simply multiply. Instead of multiplying 5 by x to the 0, it's 5 times 1. So I could write it like that. This one, it's y to the 0. That fades away, so it's just times 1. And that's how I get 5 minus this one is 4. And then all of this is unchanged. X times x to the b minus a times y to the b minus a. And then this stays the same, minus 5x to the a minus b, y to the a minus b. There's nothing we can do to fix those or clean them up. So this is our final answer. Whew, that was a crazy one, right? Okay, I hope that helped you, Vivian. That was a good hard problem. Definitely challenged me as well until I noticed that pattern. Okay, so that's how I cracked it open. All right, we'll talk about this. I'll remind me to ask you how you're feeling about this problem now. Hopefully it makes sense. Thank you. Goodbye.